Today we studied Calculus 1. The topic is Rationalizing Substitutions. How to do. Now look at the indefinite integral. Look at the variable, the square root of x. How to do. The twin radicals in the integrand are often troublesome. How to do? We usually try to get rid of them. How to do? We often use the corresponding appropriate substitution. The substitution will rationalize the integrand. How to do? Now look at the integrands involving the following form. If the h root of ax plus b appears in our integral, how to do? In the radical function, how to do? Okay, using the substitution idea, let u equals the h root of ax plus b, and then the h root will be deleted. This will eliminate the radical. How to do? Now, look at the example 1. Try to find the indefinite integral. Look at what is our special form. We write t equals the square root of x, and then t squared equals x. We will do the same computation about the two sets. Differential t squared equals dx. We can get double t dt equals dx, and then we use the substitution. Try to eliminate the radical function, so the original indefinite integral equals the square root x become t, x become t squared, and the dx become double t dt. Replace every expression for x. We can get double t dt, x t squared minus t. Look at the two expressions. There is the common factor t. T is deleted, becomes 2 over t minus 1. This form. And this form is very easy. We are familiar with this form. So, equals double ln absolute value of t minus 1 plus c. Pay attention to, we use the substitution idea. So the last step, we will replace square root x into t. So t equals square root x. So the final answer equals double ln absolute value of square root x minus 1 plus any real number c. If we understand the question, we will go on to example 2. Try to compute the indefinite integral. How to do? Using the idea. What idea? Substitution. In order to delete third root, how to do? Write the third root t equals third root x minus 4. X minus 4, and then we can get x. X minus 4 equals t cubed. So, t cubed equals x minus 4. How to do? Yes, do the same computation. Means differential add to two sets. dt cubed equals dx minus 4. So, we can get 3t squared dt equals dx minus 4. d minus 4 equals 0. So equals dx. We can get the original function, replace every x for t expression. We can get x equals t cubed plus 4. So equals x equals t cubed plus 4. Look at this term. This term is our substitution equals t. dx differentiable x equals 3d squared dt. This means the integral function only have one variable t. Together equals 3t 4 power plus 12t cubed. We can get the original function 3 over 7 t7 power plus 3 t4 power plus c. Do you remember the last step? Replace t for x. So t taking in the x expression. This is the final result. Now we will look at the example 3. Try to evaluate the indefinite integral. Square root a squared minus x squared. It is different from example 1 and example 2. How to do? In order to delete the square root. How to do? Yes, look at this. Let x equals a sine t. First, we will understand the corresponding domain. A squared minus x squared. A squared minus x squared. Non-negative. This means x corresponding to absolute value less than or equal to a absolute value. A is a positive number equals a. So we can write x equals a sine t. Mixed domain are equal, so sine t between -1 and +1. This means corresponding t belongs to -half pi and half pi. Okay? Pay attention to the domain of t such that x between less than or equal to absolute value of a. So we can write x equals a sine t. So we can get the first step equals a cosine t. Maybe you asked me, should be equal to absolute value of a cosine t. Pay attention to the domain of t. T between -half pi and half pi. So cosine t non-negative. So the absolute value become a cosine t. dx, okay? dx equals dA sine t means a cosine t dt together equals this term. Now look at integral function 1 plus cosine double t. Try to get a squared over 2, 1 dt become t. Cosine double t original function equals half sine double t plus c. Okay, how to do? Yes, replace t for x. How to replace? Look at this. X equals a sine t. T equals what? We can get t. How to do? Look at corresponding the triangle. In this is our x, okay? And this is our a. In this angular, we can get sine x. Sine every t equals corresponding x over a. So equals x over a. And then corresponding cosine t equals square root a squared minus x squared over a. So here t equals arc sine x over a. How about sine double t? Itself equals double sine t cosine t. Sine t equals x over a. Cosine t equals square root a squared minus x cubed over a. So we can get corresponding the last value. So you try to using the information between the triangle. So now we will have some summary about the substitution. Look at case 1. If there is some radical in the integrand functions, such as the case root x, else root of x, how to do? We will write the case root of x equals t and write x equals tk power. How to do? Do the same computation. Differential for the two sets. So dx equals dtk power. What is dk power? Means kt, k minus 1 power times dt. you try to make the integral function become a function of t and dx equals this expression. So the original function will be the function of t. Case 2, in some triangle special case, we will try to use triangle substitution. Our purpose is to reduce the radical, means the square root. General rule, there are 3 cases. Now, if it includes the following functions, we try to using the triangle information. We can build up a new triangle, try to using the useful information in the corresponding triangle. Case 1, if square root a square minus s square, how to do? Let x equals a sine t. X equals a sine t, the square root will be deleted. Or we can write x equals a cosine t. Case 2, square root of a square plus x square. Yes, we will write x equals a tangent t. Why? Because 1 plus tangent t square equals secant t square. So we can delete corresponding the square root. Maybe we can write x equals a cosine t. Similar meaning. Look at case 3. Square root of x squared minus a squared. We can write x equals a secant t. A secant t, and then maybe we can write x equals a cosecant t. Try to understand the 3 cases. Our purpose is to reduce the radical. So now, how to do the summaries? We will do some questions. Now look at question 1. The question 1, try to find the indefinite integral. How to do? Yes, case 1. Try to delete corresponding the 5th root of x plus 1 square. How to do? Yes, we can do something. Let x plus 1 equals t5 power. If equals t5 power, we can do the differential for the 2 sides. So dx plus 1 equals dx. dt5 power equals 5t4 power dt. They are equal. So original indefinite integral I equals the integral function become a function of t. Look at the first expression, x. X equals t5 power minus 1. This term. Look at, pay attention to. X plus 1 equals t5 power square and 5th root. So equals t square times dx. dx equals 5t4 power dt. So now the integral function become a function of t, the same variable. Go on, become a polynomial indefinite integral. 5t11 power minus 5t6 power. So equals this term. How to do? The last step, do you remember? Yes, replace t for the original expression x. How about the t? Yes, t equals x plus 1 to the 5th root. So we can get the final expression. How to understand? You have some idea. Now look at question 2. The question 2, try to evaluate the indefinite integral. Our idea is to eliminate the square root. So how to do? You can try, but the idea is more difficult. Sometimes you cannot do. We can give you some another idea. Let x equals 1 over t. If x equals 1 over t, do the same computation on the both sides. So dx equals d1 over t. 1 over t equals minus 1 over t squared dt. go back to the original function. The original function become a new expression for the substitution of t. So go on. Look at x squared. Where? Yes, this term. X squared equals 1 over t squared times square root 1 plus 1 over t squared. How about dx? Taking in this expression. Look at this expression. Okay, they have the same common factor. They are deleted. So equals this form. Minus t dt square root 1 plus t squared. How to do? Yes, square root 1 plus t squared. So we try to write it. T dt equals half t dt squared. They are equal. T squared plus 1. So we can write it. T squared plus 1. They are the same expression. So this means square root u du. So now we go on, write it. This is our original function plus c. The last step, replace t for our x. How about t? Yes, t equals 1 over x. So taking in, this is the final result. Now look at another question. Look at the question. Try to find the indefinite integral. The integral function is 1 over x times square root 1 plus x over x. How to do? Our purpose is to delete the square root. So give you some idea. Let the substitution t equals square root 1 plus x over x. How to do? Yes, we can write it this term. Do the same computation on the two sides. So we can get x equals 1 over t squared minus 1. So dx equals minus double t dt over t squared minus 1 bracket square. And then the original indefinite integral I equals 1 over x. How about 1? Yes, here. 1 over x equals t squared minus 1. This term equals t dx here. So equals minus double t over t squared minus 1 bracket square dt. So now the integral function become a new function of t. So now delete corresponding the common factor. We can get minus 2 t squared over t squared minus 1. Yes, we are familiar with this form. How to do? This term is t squared. Okay, look at it. This term t squared minus 1. We become, how to do? Minus 1 plus 1. Become some polynomials plus some real fraction. So we know how to do. So now get minus 2 bracket 1 plus 1 over t squared minus 1 dt. We can get the original function 1 dt equals t. 1 over t squared minus 1 equals log t minus 1 over t plus 1, corresponding absolute value plus c. You still pay attention to the last step, how to do. Replace t for x. So equals minus 2. How about t? Yes, t equals this expression. Minus log t minus 1 over t plus 1. We can get this expression plus real number c. This is our final result. The class is over. See you next time.